of thing happen. Anyway, I started recording the lecture here. So let's begin. Everybody open this. Okay, if you open this browser, you'd like to save it to whatever name you'd like to save it to, right? Let me save it to week 5 lecture 2 spring 2026, right? All right, and then let's begin with the class lecture. So I was just talking about the user-defined function. Okay. Now the function. Anybody can tell me what is the function? What is the function is for? So many functions you use every day, right? Something with the argument, right? So the argument is inside parentheses, right? And other things that on the functions that you learn, remember it must to be lowercase letter, right? The start letter, right? The function name needs to be lowercase letter. As an example, like you use square sqrt, right? You use absolute abs, use cos, use sin, tan, use cos t sin t tan t. All these functions that you use here, right? Several times already. Plot function, right? Subplot function, feedback function. So it's all about the functions, right? All of them are functions. Now these are the functions out of like thousands of functions, default functions they call. Out of the thousands of default functions that you used here. Okay. This means that are the functions that cover every problem in the art. No. There could be user-defined function. Okay. Right, Renzo? Say like you are in a class, you have a complex math, you would like to write a function which you're going to solve every time, that math only. Does it make sense? You have a bunch of equations. Say like a bunch of equations. Okay? You'd like to solve by using a function every time that particular custom function. Okay? Does it make sense? It's a custom function. It is specific one that is only important for you. Okay? You would like to write it as a function. And now you are calling it user-defined function because you are a user. Okay? You're defining a function. Does it mean that you can write a function which the existing function that you use? Definitely can. As an example, you can write a function which can still find the cost value, cost d value. You can write a function. Who did that? Like, when you use the cost d function or cost function, somebody did it before, right? Like cos of cos t is based on, if you're going to take advanced math, those are based on some series, right? Maclaurin series or something. I don't know if you know about it. So if you know that series, you can literally write the cost function. Okay, use your own cost function. So like cos Hori, okay? Cos Ben, cos Renzo, right? Cos Jason. You understand? You can write it. So that's the purpose of today's class. You understand? Okay. So that means that now that you are defining your own function, you got to create a separate .m file for the function. Okay, and you got to keep that .m file for the function, right? You got to keep that .m file in the same location where you are running your original .m file. The original .m file means your actual program. So like for today's class is week 5 lecture 2, right? So say this .m file is located in download folder. So the function that you're defining and you're creating completely yourself needs to be saved in download folder as well. Then only it will going to run. So your job is two jobs right here. One is to create two separate .m file, one for the function and one for the main thing that you are doing with 5 lecture 2, and other thing to make sure both of those .m is in the same location in the computer. So when your .m file is running, it is going to look for the function and it is going to find it on the same location. Does that make sense? Don't understand so far what I just said? So that other thing obviously is important when you're going to write the function, the user-defined function, your function, right? You can't afford to follow the same thing. You can't start with the capital letter, right? And there are some more syntax on the function itself, how you write, what are the contents of the function, right? But you for sure know it needs to be lowercase letter and it needs to have something on the argument. What is in the argument? On the function, all the functions that you use, as an example, square root function. What is in the argument? Argument, you're going to put like what actually you'd like to do the square root, right? So it could be a variable, it could be a number directly, right? But it is going to do its job, right? So that's in the argument. Now when there is a number, the number or the variable, you don't have to put a single quote. But when you have a character means some text, right? Then you must need to put it in the quotes, right? Remember that? So So basically, we have the idea user defined function should have the lowercase letter, should have the argument, it should have the argument should be like unit value. If it's like text, it needs to be single inverted comma and everything. Okay. So far, you guys are good. Everybody understand? Let me move on. Now I have so much to write here first, and then I'm gonna start talking about the user defined function. Alright, so first thing is the title. So this is week 5, lecture 2, user defined function. Title, description. Now all those things needs to be under comments, right? Creating our own functions in Octave or MATLAB. Okay, the main code. You know what is the main code, right? Main code is CLC, clear, close all, right? Those things, you know this. And let's give a little bit of formal lecture here. I mean, formal class notes, right? What is the user defined function? The thing that I said, okay? So user defined functions. What does it mean? So it means we can create our own function in Octave or MATLAB. They will work in a very similar way to Octave built-in function. So they are useful because we can use them to replace portion of the code. Okay. To replace portions of code and speed up the time to code things we do on a regular basis. Now that is so important here. Say like you have only one math problem that you are doing it for one homework. You don't want to write a code, use a different function for that. But say like you have a projectile x and y equation that you'll be using every time, right? So then maybe you want to write that, like use a different function. Every time you want to call this. Does that make sense? By the way, we'll be learning how to write that, what I just said here, okay? Okay. So then let's learn a little bit about the syntax. You know, the syntax means the grammar, right? The standard syntax for calling a user defined function is a syntax. I'm now giving you the syntax. So you should have a bracket and the output. That's how you're going to call the function, okay? Equal function name input. So for example, let me give you an example. Say like you have this answer is the output equal sin d theta. So say like with a real example that p equal to sine d 45. Here this is the default function that I'm using, but as I said, we're gonna learn how we're gonna write this thing as well, okay, at some point, not here, but this is just one of the example, and I have some more notes about the user defined function, okay, shortly after this, finish the typing. Excuse me, everybody's good so far? Okay, perfect. Now you can run it and you will be seeing the p-value is 1045, that's fine, but that's not everything. Let me put some info or reminder. So in general, about this user defined function, in general, we make functions for operations that we want to repeat often. Okay, so we don't have to type out all the stuff every time. I did talk about it, right? So if something repeated, then you may wanna write a user defined function. If it's a single time deal, you may not even bother to write a user defined function. Okay, always suppress all output in function using semicolon. That's so important. Always suppress all outputs in function. In function means inside the function, whatever math that you are doing. I mean, you only job is to show the outputs only. Okay, remember the syntax: output inside the bracket. That's all you'd like to show. Okay, not what happened inside the function. Okay, always suppress all the output in function using the semicolons. You never want the hidden side of the function to display to the command window. This is point number 2. You may want to keep a space. And point number 3. The names of the variables don't matter when going from the calling script to the function. Just have to be internally consistent within each individual script. Just when you see it correctly, you can see it. I just reduce the size a little bit. Okay, that one is so important. Like first two is easy to understand, right? The semicolon not to show what happened. inside the user defined function. You understand, user defined function is a separate .m. On that .m, whatever you are doing operations, say like you have 4 or 5 equations, right? You are solving to find one final thing. You don't like to show 4 or 5 equations result. That's why you'd like to put a semicolon. Is it clear? All right, so the third thing, it says the name of the variable don't matter when going from the calling script to the function. Okay, just have to be internally consistent within each individual script. So that's so important. Related to that, try to understand what it says. Remember, there are 2 scripts, right? One is the function itself, another one is the main code, right? So it says here, when you're typing the user defined function, the variable needs to be consistent. What variable that I'm talking? The variable you have on the function itself, in the argument you're going to have the function. When you understand what I'm saying, right? Sure. The function, don't worry about too much about the typing, because these are just the notes, okay? Because you're going to have the access of this, and this class upload it. Not only that, the left is a video record, you can see it here as well. So important what I'm saying, you understand? Okay, so you have these 2 data files. One file is what? Like they use a different function, what you're writing stuff, right? So that you remember the definition of the function. It does have arguments, right? In the arguments, what you usually have? Like the variable, different variables. As an example, say like you have these x and y coordinate values that you're trying to explore, right? Those are the arguments. Now, inside the function, when you're writing it, right, so you have the equations for x and y, right? Make sense? So in the second one, I said just put the semicolon, so you don't like to display those, right? You understand? The third one I'm saying, see, when you have that x and y in the function itself, and you're writing that x and y equation in the function itself, in the user defined function, it doesn't need to be matched with your main script when you are calling that function. Is it clear? So when you're defining, you having the arguments say like x, y, z, m, like 4 different variables, right? You use those variables. Now when you're calling it in main script, you may not have to be consistent at all with those x, y, z, and m, those 4. You may be choosing, instead of those 4, you may be choosing a, b, c, d as a variable.
So they're just placeholders.
The placeholders, exactly. So in the function itself, you got to be consistent. Wherever you are using x, y, z, d, x, y, z, m, you got to be consistent inside that .m file. It's a separate file, right? Whenever you're writing it, that needs to be consistent. Everywhere that needs to be there. But when you're writing the main code, when you're calling that function and inside the parenthesis on the argument, you may type instead of x, y, z, m, you may type a, comma b, comma c, comma d. Because in the main script, right, you have this a, b, c, d. That's what you are using to do the math, not x, y, z, m. Does it make sense? That's what the problem is. And I know, even though you agree that you understand everything, before you see the practical example, you won't be feeling it. We have practical example for that, okay? But this is just the definition. Number 4. So remember, to save the function. This is so important. It's kind of common sense. So if you make changes to the function, must press save button again to update it. This is the obvious thing. Like that's the thing I all the time emphasize. I see some students, they just run without saving it. Please don't do that. Save every time, okay? If you don't do that, the result will not going to get displayed like the way you want. Maybe in main code you are able to get away, but not in the user defined function if you don't save it. Okay, and then number 5. So we never. That's so important. We never run the user defined function. We never run the function. We call the function, okay, in the main code, but never run it. Call it from our main script. That's what I've seen always, all the time. How many years I'm teaching this? More than 5 years for sure. This single course, I mean this course. So every year, every time I saw students, and every year, every time I saw students do the same mistake. When time comes week 5, they try to run the user defined function. You don't run the user defined function, you just call it. You just call it in the main script, okay? They try to run the user defined function. You are planning to run the user defined function? No. So you're gonna call it only in the main script, okay? That's what important. Okay. Number 6. We can run the function from the command window as well. So this is a fun fact. I do have an example then. Okay, giving you some time. But let me just write the title of the example, okay? So example 1. Function to calculate a polynomial. Okay. So given the polynomial 3 multiplied x cube plus 6 multiplied x square plus 2 multiplied x plus 10. Okay. So you have this polynomial, you would like to create a function which will have this polynomial. What does it mean? It means you are writing a function which is going to calculate this polynomial, where in the main script you are not doing anything with the polynomial. You are just saying you got to write it in somewhere else, okay, which we'll be doing shortly. But in main script, you define this x, okay, say like x equal to 10, whatever the value x you want, and then write, just like the syntax that I gave you, write the line to call the polynomial function. Now what is this polynomial function? That we haven't write it yet, but I'd like to show you something very interesting. Say like polynomial function is poly, that's how you're defining it, and you are trying to call it here. See what happens. The computer doesn't have the poly function written before. It is not going to run. You have to understand, you're going to write a function poly separate in a separate area. So open a new file. If you're done with that, I mean you try to run it. Just see. Save it again. Did you save it? Go to the command. That is not working for you? Why? Did you define x equal to 10? Okay, so what is happening here? It is getting the value from the poly default function, whatever it is inside the whatever MATLAB platform, okay? And it's returning the value back based on that, but not what you have here. You have a poly equation which you are planning something completely different, which is what, like 3x cubed plus 6x squared plus 2x plus 10. It's not s, it's x. This is what you would like to explore, right? Oh, I wrote x here. Why it shows s over there? Interesting. Oh yeah. sorry, I wrote X. I have it open here in separate screen. So what it tells you, you're going to write a polyfunction. Everybody's done up to this? So let's write a polyfunction. So let's create a separate .m file. Everybody open a new file. Don't do anything with the previous one. You saved it and keep it as it is. Okay. Let me save it. Keep it as it is. A new file just created. Okay. And then you want to make sure it got saved in the same location. Okay. To a file name, you must have to make the file name as poly. You must have to make the file name as poly. Okay. And then if you save it, it will gonna be poly.m in the location that you just saved it. Okay. Once you save this, then you would like to start the function. The way you can do it, the syntax is you have to start typing like the function. Okay. And then remember the syntax that I was showing, like you have to put the output. Let's put some variable. Don't worry too much about the variables here because as I was saying, this variable doesn't need to be matched with the variable inside the main script, right? So let's say the p is the output here because that's in the bracket equal. So then the function name, which is poly, and you want to put a argument b, and again this b, don't worry about that, it could be x. I'm just showing different so you understand. All right, and then you'd like to write the poly function, but let me explain this what we're doing. So this is the poly calculate the value of a specific third order polynomial. Is good? Okay, now it's time to write the actual function. And remember, p is your output, so capital P. Now it depends, if you write small p is fine. And then your equation, this 3x cubed plus what is that? 6x squared plus 2x plus 10, right? So should I write like the x or b instead of x? Should I write b? You understand? I mean, remember the 3, what is the equation I had? 3, let's write the equation, okay? Let's write something something differently and then see if you comment. So 6 x squared plus 2b plus 10. Okay, so few things I'd like to discuss before I put this. And okay, so now tell me something. If I was save it and try to run the main script, do you think this function is going to work? Why? Exactly. So the variable is a parenthesis or an argument, right? And the variable I wrote b, right? But inside the poly function, what I have x, does it match? Two different variables. So it needs to be either x in the argument, or it needs to be either b on the main script, right? There's no way we can deal two things. So we're gonna make sure this thing is instead of x, it is b. Just here's another thing that I'm showing, okay, so that you understand. It really doesn't matter if your equation doesn't have x cubed. It really doesn't matter if you have x or b or m or whatever, right? Does it make sense? All right. So other thing, the poly, that capital P equal to that equation. Should I put a semicolon after that equation or not?
Yes.
Why? I don't have to like to show the thing twice, right? Why? So everything that you are doing inside the function, you would like to put a semicolon. So you don't like to show it in the command window, right? Everyone understand so far? Then you want to save it. Okay? If you're done dealing with this, what I just said, then you want to minimize it or close it, doesn't really matter, but open the main script. Okay? This is my main script. and then try to run it again. And then you'd be seeing the output value is 3630. It was no longer minus 110, right? It is?
Why does it say P equals 0.70?
Oh, the P, remember we had defined sine? There's the sine.
Up top. Okay.
Yeah, that was like, you know, that was to show you sine 45. Any question? Everyone understand? Does it run for you, Renzo? What is the value got?
I want to know. I want to say you can go back to the function on the poly one.
So because
Yeah, because I have name. Oh, gotcha.
Is it running for you now? Is it running for everyone? You got that value? Renzo, you got the value now? What is the value got? Is this like 3630? Everybody got 3630, right? Renzo, you got 3630 for the output?
Can you go back again to the thing? I don't know.
It needs to be capital P here and here. If it is a small p, it's fine. Okay, and this B, if the argument is B here, in the equation here, everything needs to be in B. Okay? Okay, the main code.
Okay, B is undefined near line 4.
Did you save it in the same file? Is both of them are saved in the same file?
Yeah.
Same location? I'm coming. You type everything correctly, like the function name, and did you put the bracket, did you put like the, found anything got it?
not that I can see.
No.
Wait. Here in the space between poly and parenthesis. Try that.
Ah, so there's a space. Okay.
You gotta run this one.
That should do.
Everything looks good now, but I
Still
can't
running
see it.
still? Okay, let me run. Let me solve. Ah, yeah. You saved it with a capital B. You saved it with a capital B. Remember, I said it must needs to be small letter, lowercase letter. You see, it's small. That's capital. It doesn't match, and it must needs to be. Where did you save it? file name was user defined file name was capital B. So the reason I'm saying it to everyone, because see, this is what you may do mistake. File name must needs to be lowercase letter. Must. It's a must. All right. So moving on, right? Moving on. Okay, now example 2. Okay, let's do another example, okay? It's example 2. Function for the quadratic formula. You guys know quadratic formula? What is the solution for a quadratic equation? It will be minus b plus minus b square minus 4ac square root divided by 2a, right? So plus minus gives you two values. So that's what the quadratic equation, right? What if you'd like to write a function for that? So that's what we're doing now, okay? All right, so this is your example 2, and then you are, let me give you a little bit more. Say we have a function which is x square plus 5x, okay, plus 6 equal 0, right? And we want to find the value of x, okay? So then use the quadratic formula. So use the quadratic formula. So then x1 comma x2, remember the two values like plus and minus, minus b plus minus b square minus 4ac, so plus minus gives you two value. Those should be equal minus b, right? I'll just try to keep it same way, plus minus square root, right? B square minus 4ac divided by 2a. So this is the solution. So use for equations of form ax square plus bx plus c equal 0. You are defining the constant. Define the constant. So see, I would like to stop here and give you some time. Whatever we did so far, for example 2, is just simply write the equation for quadratic formula. So equation means that the two solution x1 and x2 minus b plus minus b square minus 4ac square root divided by 2. Thing that you say. That's all I did right, and I give you equation. And I said like solve it based on that equation, right? So remember, I had like ax square plus bx plus c equal to 0. That's what the result is for, minus b. Remember that x square plus bx? Seems like you guys are still trying to remember. Remember, so that's the equation, x square plus bx plus c equal to 0, right? Where the x is equal what? Minus b plus minus b square minus 4ac divided by 2a. Everybody remember that? No? Yes? Does you remember that? It's called quadratic equation, okay? If you have x squared, that is two results. So now, obviously, you understand. If you have a plus and minus here, then you have two results, x1 and x2. The same thing I'm writing again, so b square minus 4ac. Okay? I give you equation to solve it. What is my equation? I have equation here, x squared plus 5x plus 6. So x squared plus 5x plus 6 equal to 0. What is my value of a, b and c? Tell me.
156.
X, a is what? What is b? Ranzo, what is b? In my equation, what is b? X squared plus 5x plus 6 equal to 0. What is b compared with this one? Is it 5?
No.
Is 5 goes in b? Right?
Oh, B is the first variable, yeah.
Yeah. Sorry, the writing a little distorted. This is 5 as talking, right? So this b multiplied x, so that is 5. Understand? Renzo?
Yeah.
Okay. So what is c? Jason? 6, right? So understand. Okay, this is the simplest equation, right? Quadratic equation. Okay. All right, let me write them. So you have this a equal to then 1. You'd like to put semicolon, right? You don't like to show this ABC. B equal 5 and C equal 6. Okay. Now you'd like to call the function as if like you already wrote the function. Did you wrote the function? Not yet. Okay. So let me put that. So call the function. Now unlike the last one, remember I had the syntax. When I have multiple result, then the syntax says the output needs to be in an array. So the bracket needs to be there, right? So why I'm writing array? Because I have how many results I have? Quadratic equation. 2, right? So I should put a bracket, right? And then I should put output 1, output 2, answer 1, answer 2. Doesn't matter, whichever way you want to say. But you have 2 outputs for sure, right? So that's what we'll be doing next. So you can say answer 1, answer 2, doesn't matter. What is the name? Whatever name you want to put, but you have these 2 output. Then say like you wanna name this function called quadratic. Okay. And then just tell me something. How many variables I'm gonna put it in the argument? And if you know how many, what are there? What are the inputs to solve this answer 1 and answer 2? What are the inputs to solve the value of x1 and x2 in other words? ABC, right? Those are my inputs, right? ABC. So how many of the variables that I need to put in the argument? 3. Those are A, B, C. This is good, right? Does you understand? A, B, C. Those are the variables that I'm going to put it in the argument. So A, B, and C. Now I know back of your mind you're probably thinking what you're going to do. Like you're going to write that quadratic function, right? Open a new .m file. If you do anything, open a new .m file and try to write the function, okay, where you have those 3 inputs A, B, C, right? And you're gonna have to have these equation, this x1 and x2 equation, okay? Inside the function, inside the .m function. Okay, so I'm saying just open a new, okay, save it and open a new .m file. Okay, before I do that, okay, tell me something. Is everybody done with this typing? Whatever is here, everybody's done. Just know it's still working. Okay, finish this, and then I'm gonna start typing that .m file. Everybody's done. I'd like to finish at least that .m file for the example 2, so Corey can finish that one because he has to run for the different class. Everybody's done?
Sure.
Okay, gotcha. So the .m file. So the .m file, before I do that, let me open these notes of mine. So quadratic function, let it open first. Okay, so here this .m file, you gotta first save to quadratic, right? So Okay, so quadratic. So QUADRATIC, quadratic. Okay, so that's the function, and that's all. So remember, don't put the cap letter starting just like before, right? So quadratic, the function gets saved in the same location. Okay, so then you'd like to start with the this is syntax. You first want to start with the function, okay, before you do anything, and then remember you had these two answer. Now this can be answer 1, answer 2, or it could be anything else, x1, x2, doesn't really matter. Okay, I don't know, maybe let me show you x1 and x2, that way you're going to see some difference. Okay, and then you have this quadratic, again quadratic, that's the function. So then you have a, b, and c, right? And then let me explain a little bit. So this is what, like quadratic, sorry, so quadratic calculates the roots of a polynomial given the coefficient a, b, and c, right? Now it's time to write the actual function, which is x1 equal minus b plus square root b square minus 4a. So make sure you put a asterisk in between 4a and c. Okay, oftentimes students do mistake here, and make sure you close the parenthesis. See, one thing to notice, you see, when I type the parenthesis, or I'm closing the parenthesis, both are in blue, right? The start and the end. So the parenthesis needs to be closed, otherwise the function is not going to run. So that's the highlight that I'd like to make. And then 2 asterisk a, and you'd like to put a semicolon, right? And for the second one, which is x2, I'm gonna simply copy it, right, and paste it here by changing this thing to and changing this thing to negative, right? Might be seeing it much better now. And then I'll just simply end this. That's my function end, and I'm going to save it, and it should be running now. If you're going to go to the main script, okay, remove it faster because I'm not going to finish this before that. It's running. I bet you guys are started feeling comfortable with the user-defined function, right? Everyone? Just when you're feeling comfortable with the user-defined function now? Kind of? You need some more practice on the homework. Okay, I'll upload the homework. The second equation, if you copy the first one and change the plus to minus, that's it. Very good. Cardi, you can leave now. Okay. At least you have something fruitful. Yeah, it's running for you. Yep. -2 and -3. Yep. And this save. Go to the main code. Run it.
No.
SQRT. Go to the what did it? SQRT. Square root. For both cases. Top line also. Yeah, it's not. Save it. Yeah. We have it now. Okay. Anyone wants a break? Jason might need a break. He's with me like until you start at the same time the class with me. Get a 5 minutes break, okay? At from 9. or you have class at 8 also. You need a break. Just go, relax. I feel like I need a break. I was like standing from 9. নোরের ওষুধ খাওয়া কিন্তু ওকে আমি ক্লাসের মাঝখানে সময় রাখি কাজ আছে হ্যাঁ ওটাই এটা আমি মানে রাত্রেবেলা চোখে দেখতেছিলাম না তো ভুল করে টাইপ করতেছিলাম গুগলে ওটা পোস্ট এমবিডিতে টাইপ হয়ে গেছিল সানরাইজ অর সামথিং সানরাইজ টাইম পোস্টে ওকে ঠিক আছে আর ক্লাস শুরু হবে না আবার একটু গ্যাপ আছে সকালবেলা যখন উঠছি যখন দেখছি তখন ডিলিট করছে হ্যাঁ ঠিক আছে আর রাখির সময় আমার ক্লাস শুরু হয়েছে Okay, everybody ready? Should I begin? Jason, Ben, you guys are good? Should I begin? Need some more time? Jason needs some more time or good? Good? All right, let's start. All right, so a few reminders here, okay? We have written two user-defined functions. So let me start with this. I actually didn't see myself whether my code is running. Let's see. Yeah, my code is running as well. So reminder, as I said, like few reminder here. So reminder or info. So the order of the inputs in the functions matters. Okay, Octave will use the evaluate the same order and won't care what you call them, as you have seen, right? Now I've seen some of you call in the function, like, you know, instead of x1 x2, some of you call like answer 1 answer 2. So many ways you can call them. Like Octave doesn't care really, okay, as long as it matches it to its place. Okay, all right, so then we're going to start with example 3. So that's the engineering problem. So let's start with that. So given a equal 0.5 t, write a function that will calculate acceleration a, velocity b, and position s for an array of t values. T is the time here. Okay, so you're going to write a function for those, and basically this is for the motion equation, x and y equation. Everybody remember the motion equation for a projectile? Ben, remember that equation, motion equation for projectile? We did the plotting, right? Yeah, the other day. That's the equation we'll be doing now. Jason, you remember that, the motion equation? Ethan, you remember the motion equation? Like the plotting equation, remember? I mean, we did plot, right? The x value, y value, xy value. In last class, subplot, remember? No? Yeah. Okay, perfect. So that's what we'll be using. So let's start with the define the parameters, right? So like your first parameter is initial velocity, which is 0, and then you'd like to put a unit, which is meter per second. You can say this is the initial velocity, right? Then initial position, SO, equal to 0 as well, right? And put the unit, right, meter. So that's the initial position. Then this t0 is the initial time, right, with the unit of second initial time. See, every time I started typing initial INI, it shows up, do I want initial? Then I press enter and I don't have to type. So Octave is much easier that way. You don't have to type everything, okay? So remember the interval, the time interval for the time matrix or final time. We'd like to define like the final time is 30 seconds, right? And then you're gonna put the unit as like second, and then you're gonna say like, okay, this is the final time. And then the dt is say like the time increment, right? Which is say like 0.1. And then you would like to type say like s is the time unit, this is time increment, okay? And then obviously you'd like to define the time matrix, which is t equal to colon dt colon tf. Now instead of defining these variables to, tf and dt, you could have write like 0 colon 0.1 colon 30, just like the other day. And then obviously you'd like to explain the units it as, and then say like this is your time matrix. Now friends, it could be kind of new to you. You missed so many classes. We did learn matrix here, okay? You was in the matrix class?
Yeah.
Okay, perfect. Okay. So then yes.
Other than VO the first line, is that SO, S0?
Yeah, I did. Yeah, that's the SO, but I have a typo here. I'd like to clarify that. So it should be VO, not V0. Okay. There's a difference between 0 and O. Okay. So just make sure you don't type it wrong, otherwise you're going to get wrong result. And then we're going to obviously call the function where the function needs to be still defined. So call the function to calculate A means acceleration, V comma velocity, and S. S is the position. Okay. And then anytime you have multiple output, which is in this case A, B, and S, right? You can put a comma or you can put a space, really doesn't matter. Anybody remember when you have a space, what does it mean? Is it like a column or row?
Row.
No, row is like a semicolon, column. Comma and space, anybody remember, are those the same thing or not? Those are the same thing, okay? So that means you can skip the comma as well, doesn't really matter. Just different way of showing the same thing. So then you need a motion function, right? Which you haven't started yet. And then you would like to put, what you would like to put? Some arguments. What are those arguments? Like all those different things that you define, like this VO, SO, this TO, this T, initial time, the time matrix, the initial velocity, the initial position, okay, all these things. Now you may keep a space after this, you may put it without a space, really doesn't matter. Now I'm skipping the steps, okay? And then you put a semicolon on the output itself, because you don't like to show the output here. Why you don't like to show the output here this way? Anybody? How many elements in the time matrix? A lot. So you start from 0 to 30 and with a 0.1 interval, more than 300, okay? So after you write the equation, how many of the acceleration and the velocity and the position you're going to get? 300, right, Ethan? So 300, 300, 300. So do you really want to see all 1200 values in the, no, you don't, right? So you want to put a semicolon for sure here, but you'd like to see the results. How are you going to see the results then? What is the best way of seeing the results? You'd like to see the results, right? What is the best way of seeing the result? Not by data.
Do you not put the semicolon in the function? Do you put it at the, or that also get all?
That will also going to display, but the best way could be, isn't it like plotting a figure? The plotting figure, no matter it's like 300 data points, 30 data points, or 3 million data points, it will going to still show like a curve, right? It makes sense? So we're going to display it in a plot. But before we even do that, we need to have this function, right? The motion function. Otherwise, nothing will going to work. So let's do the motion function. Let me know when you guys are done. so I can start. So I opened a new script, right? Just like before. What do you want to do here? Save it to, what would be the file name you'd like to save, Renzo? What would be the name that you'd like to save? Use a different function you're writing, right? What would be the file name? Isn't it motion? You understand, right? Because I'm calling motion, so make sure you write motion. Okay, then what? Then start, every time you start typing the, use a different function, start with function, okay? The first thing you want to do. So function, and then, you would like to define a array where you have this A, B, and S, right? Remember previously I had this comma. You can put a comma here also, doesn't matter really, it's the same thing, right? A, B, and S. Now you may argue, okay, here this A, B, and S, and in the main script I also have A, B, and S. Does it matter? It doesn't, okay? So I'll just stick with A, B, and S because we know A is the acceleration, V is the velocity, S is the position. So that's the reason, nothing else. And then I'm gonna type the function name, right? Motion. And then in the argument, how many arguments I had? Like the same thing, right? I can again put like X, Y, Z, T, whatever, but I'm gonna keep with the same name, right? So you know it is what we are referring by. So VO, SO, TO, T, right? Remember? Again, this name can be different, but it really doesn't matter which name you're going to choose. You have to consistent here. And then I'll just put some notes. So like motion calculates A, B, S given some T matrix, right? Not the matrix type, matrix. Okay. And then I'd like to put a note here. So note. So use the short means indefinite solution here rather than the definite solution. What does it mean? Which means which use VO, SO, and TO. You see, I'm going to simply skip those three things, VO, SO, and TO, because as I mentioned here, use the short or indefinite solution rather than the definite solution. Definite solution means like you have done the definite integral, indefinite integral. What is the difference between definite integral and indefinite integral? Anyone? Everybody done with the calculus class? Okay, definite integral means when you have a limits, right? And when you don't have a limits, that is indefinite integral. So I'm saying like, okay, I'm solving it in an indefinite solution. So I'm skipping those initial values as if like I don't care about those initial values like VO, SO, and TO, right? Only thing I need here, the time only. Does it make sense? So integration definite means the limits, okay? Lower limit, upper limit. Usually that refers to the initial values, right? We are not dealing with the initial values, okay? All right, so then let me write the equation for you here. So I have this A acceleration. The acceleration equation is 0.5 multiplied t. Now you may argue, how come you come up with this equation? How come you come up with this equation, right? Now you could have your own equation for motion, right? Based on the math that you are doing. This is not math or physics class. Okay, we are just implementing what you already have here, right? You understand that? What is the purpose of this class? In this class, you are given with some equation. You'll just implement that equation in the coding. Okay. So say like you have this code, as you have these equations already, A, B, and S. So A is like the 0.5 t. Okay. And then you'd like to write the unit, which is meter per second square, and that's your acceleration. Don't forget to put what? Don't forget to put what? The semicolon after every line, right? So then the velocity v equal t square divided by 4. Okay, now you can put a parenthesis on this t square or not. Really doesn't matter, excuse me. So you're gonna put this comment here with the unit where it's meter per second, right? This is velocity, and finally the position. Position, say like position. Okay, you see me putting a dot before the square sign. Why I'm putting a dot? Or here, why I'm putting a dot before the t cube here? Anybody remember? No? No one? Ethan, do you remember why I put a dot? Because if I have exponential which deals with the matrix indices, I must have to put a dot, right? So every element of the matrix needs to be squared, not only one single one. Otherwise, it will not gonna work. Okay, Ranzo, you missed this class. Okay, remember that. So you have this thing is in meter. This is a position. Okay, then you'll just simply add this function. Okay. Then you can save it. I'm giving you some time to finish copying the class note, okay? Let me know when you guys are done. It was done? Why not do that? Just come here, save it, and run it, and see if it runs. I have an error. Okay. So DF, let me fix that error. So it should be TF, not DF. I have a typo. I'm highlighting the typo in case if you are copying my work. It should be TF, not DF. If you type DF, it will not going to work for you. So I'm running it again. Yep, this time it is running. So it seems like the code is running. But I'm not seeing anything on the command window. Don't worry, I'm going to display it in the figure, right? All right, so we are at the very end of this class, okay? Now we'll just do some figure, okay? Some plotting. All right, so let's do that. So we have to plot or show the result. So show the result. I did give you the pitch already, right? Why you need the figure, right, Ben? Why do you need the figures? A, B, and S, how many values that you would be expecting? For each of them, 300 around, right? So 900 values you can comprehend. It is impossible to comprehend. So you need a figure, right, to display. What is A again? Acceleration B, velocity S is position, right? Everyone's with me, right? No? Ranzo, you understand?
Yes, sir.
All right. So, okay. So if everybody is with me, result, show the result by plotting. You want to do figure 1. So on the figure 1, obviously you would like to do subplot. Subplot 3, 1, 2. What does it mean, 3, 1, 2? Anyone? Ben, you remember what is 3, 1, 2? Hmm?
I asked to do where the graph goes, right?
Why what the graph goes basically? That's the last one.
Yeah, I forgot.
First two means 3 means number of row is 3, right? So 3 plot. 1 means just one column, so 3 plots, right? And it goes to the second one, like second location. You got it, Jason? Remember that 3 comma 1 means like how many plots? 3, right? 3 row, 1 column.
Yeah, like I know that part, but I don't know what it actually means. Like,
So like
what position is there? I don't
the position number 2, that's the first one I'm saying. 3 comma 1 means 3 rows and 2 columns, and number 2 means like the position 2. Okay, you can start with position 1 again instead of 2. You wanna do it position 1? Let's do position 1. How about that? So you have 3 plots, one after another. The top one we are doing, right? You agree now, Jason? 3 is 3 row. Subplot, right? 3 means 3 row, right? First 3. 1 means 1 column. So that means 1, 2, 3. 3 figures. You understand that? And the last number is for the position. 1 means like out of this 3 plot, you are talking about the top plot. Understand now? Renzo, you got it? I'm assuming Ethan, you got it, right? Ethan, you understand, right? All right. So 3 comma 1 comma 1. Okay. Let's start with that. Okay, so yeah, I mean, I guess like I got to do some explanation as well. What does it mean? So it means in the argument you have number of rows, number of columns, then the final thing is the position. So that's your subplot, right? And then you want to do plot actual function. You have this t comma a. Okay, you can do other stuff here like the line width, line color, line style, you know, font type, font color, font size, everything you know that, right, already? All right, so I'm not going to do any of this. I'll just simply put X level and Y level. What is the X level here? Don't forget to put single quote, right? This is time, second. And Y, what is your Y level here? What is your Y level, guys? Anyone? Okay, the first one you'd like to put out of 3, just the acceleration, right? Because you have TA, so that's the acceleration. With the unit of meter per second square. What is the title? You can say it this way. This is acceleration as a function of time. Okay. Okay, something really weird happening here. What is that? The title function is acting up. Let me hide the title function. What is happening here? Okay. Oh, that's the reason. I think like, what is happening here? I didn't quite finish it. So then title. So title is acceleration as a function of time. Now it should work. So let me save it and run it and see what happened. This figure 1 showed up here. All right. I'm going to put a title here. A, which is plot A as a function of t. Okay, and then I'm gonna do a little shortcut here. I'm gonna copy and paste, and then I'll just simply change some of the things. Like v is the velocity for the second one, then position 2, and then v is the velocity here, and I'm gonna simply put the meter per second here, and I'll just simply change this velocity, and I'm gonna simply change this velocity here. I'm gonna change this to small a, and then I'm gonna copy that same thing again, and I'm gonna paste it here. I'm gonna change it to C. I'm gonna change it to S. I'm gonna change it to 3. I'm gonna change it to S here. I'm gonna change it to position. I'm gonna change it to meter only. I'm gonna change it to position. Okay, if my code is okay so far, it should be running fine. If the code has the issue, which most likely I do have the issue on the code, and I'm giving you time to take the class note, and then we'll figure out what is the issue with the code.
Gabriel, I was having the same error as you, but when I changed, you put line 101 sub plot, but I put it to sub plot, and it worked. You see line 101, you put sub plot, I just put the plot.
Oh yeah, that's the thing. That's the reason, because I have a typo here. That's why it is not showing subplot, right?
So that one the chart came up.
Yeah, thank you. So yeah, in my personal computer it was running. It was not running here. I was wondering what is the issue. Now obviously that is the issue. Thank you, Renzo. So there is a type over there. And it should be running this way, and this is the last thing that we are doing. If you're done with the code and understand everything, you are actually done. This you can go half an hour ago. Okay. There's no more agenda for me here. Okay. Yeah, if you're done. Do you guys have any question? Can you understand the thing today? Isn't it good?